Thank you, Sal, and thank you for your invitation. And we are living in Sweden, living in the cold Sweden, coming to the warm Florida is excellent. There is at least some excuse that I'm doing some presentation today. My name is Nevzat Ertan. I'm the head of digital machining and architecture, and we have roughly 20-25 architects working with that. And the application is I can just about the Sandvick and a little bit Sandvick Coromant, and about what we are doing. Lesson has been learned. Oh, microphone, sorry. Is it better? And lesson learned from our journey about the last 3-4 years, and finally I'm going to show you some live demo. I'm going to cut the number of PowerPoint presentation, roughly 6-8 presentation we have, just why we are doing that. Most of the time is going to be, rest of the time is going to be more on the live demo. We're going to connect to one of our production centers in US. We will just check this live demo. I don't know what's going on. We need to check one of the operation machines and exactly see what this machine is doing, streaming data from the machine and doing the analytics. And I'm going to explain you all the levels what we are doing in there. If you couldn't find any machines, and we can just only jump in the production units in Sweden or Asia. There is in 3 layers, but we have testing that. And for your information is that we have never ever showed that application. It's live demo. And this is the first time we're showing in this conference. And this is going to be slowly launched as a customer-centric application. But we are using that particular application by itself in our production units and learning a little bit more about that. Application is being developed and trained last 1.5 years. And we believe that is in Q3 is ready to use that. There is 2 different purposes of that application. Okay, a little bit about the Sandvick. And Sandvick, we are part of the Sandvick group. And the Sandvick group is roughly 150 years old. And there is 3 business areas inside the Sandvick group. It's in Sandvick mining, rock technology, machining solution, and the materials technology. And we're going to be we have 48,000 employees and representing more than 160 countries. And we're normally going to focus today on one of the product area called Sandvick Coromant. There is 4 different product areas inside of the Sandvick machining solution. One of them is the largest one is the Sandvick Coromant. I have 2 different roles. I have a role as a chief architect and manager in the Sandvick group level, supporting all other business areas, and particularly the last 4 years as a special role as a head of architecture in Sandvick Coromant for the digital machining. If you check on the Sandvick Coromant, and is roughly we have representation on the 150 countries, roughly 8,000 employees. We have introduced 6 new products every day. And we have 3,100 patents every year. And this is the size we are working right now. The company has, last year in December, we had the 75 years old celebration. Whole company, Sandvick Group's more than 150 years old. And the Coromant is half, 75. And what are we doing? We are working with the cutting tools and tooling solution for manufacturing industry, aerospace, automotive, and healthcare and oil and gas. And application in there here is turning, milling, hole making, holding, and of course, services and support. And this is one of the case that's very healthy business, and we are doing very good, especially the last year wasn't our best year. But during that, doing that digital transformation is not so easy. I can tell you that it means you need to convince people to think a little bit differently. And normally studies, for us, it started the background, the future manufacturing study starting almost 5 years ago. January, February, and there is a couple of business intelligence guys visiting us saying that we saw some trends. And we've been in Germany, we saw some trends. There is the smart factories, there is Industry 4, there is industrial Internet of Things. Well, immediately, what we have done after a couple of months and identify the 5 different areas is very important to us. One area is human competency. Do we have a right competence in the company? The second one is what about the sustainability? Do you need to support about sustainability? We need to give something more to the customer. Service, support, products, we need to be supporting the sustainability. This is a good chance to have to prove that. Intelligent manufacturing, of course, this is another area we focus on. And finally, materials and the metals. In the meantime, we have a materials company, and the cutter on each tool is a tungsten carbide, and we have a large tungsten carbide research going on. The new material called the graphene, that you can have the sensor embedded material. There are so many things going on right now. It's important that focus on that. You may be thinking about that is we normally say that, where is the IT? Because most of the initiative we are doing here is not on the IT department. In that time, I worked supporting the R&D in the product management department and explaining about IT, because nobody wants to talk about the IT in this time. Because IT is some back-end processes, boring, nobody wants to touch it, simple business processes, etc. And then we changed the name to make them more, attractive. And we said that is the information communication technologies, which normally digital machining is using. And suddenly it's all door open, and that everybody's welcome us and see about what you guys are doing. You more be thinking about that. That was a key enabler of everything we are doing, human competency, sustainability, intelligent manufacturing. The second lesson we have learned about, this is not about streaming data from shop floor, sensor swarms, IT openness, to something intelligent on the analytics level. Normally we chop this at, what are we looking for? Just on the streaming data from the machine and do something about that? Or are we including our business processes? Very in the beginning, I remember after end of 2013, the same year, and the management come back to us and said, we're looking for a collaborative productivity. I need the right-hand side, which is in IT, ICT, and analytics and the shop floor connectivity. Don't forget about the left-hand side, which is the normal business processes. If you're working in that area, is in one hand side, you see that, I have a business processes, information model, and I need a cooperation, I need the social and the business collaboration tools. And the other hand side, which is you need to design time thinking for your processes. The other side, you need to think the runtime, which is the data model, because you're streaming bits and bytes from the machine, from the tools. And that was the combination we worked very hard to make that. Normally we call in the horizontal processes, which is the left-hand processes, traditional business processes, together with the vertical processes, which is on the more IT, OT type of a processes. Is the horizontal processes is this process, and the vertical process is more on the streaming data from the machine. Second lesson learned regarding on the what kind of dynamics have this kind of solution. If you combine left-hand side and right-hand side, and you do some kind of value transformation. If you just look at the left-hand side, it's a typical traditional value chain. You do this, you do that, you do a little bit green, a little bit yellow, and then you send something. This is a typical B2B and B2C type of a connectivity, traditional value chain. This is not good enough using to B2B or the B2C type of a solution to reach the customer. And we immediately said that probably it's going to be a completely different ecosystem, and we can't take everything we have on our traditional. We need to be member of those or partner of those ecosystem, and the value system create value together. We can't do everything by ourselves. We need to have some input from the others and then create some kind of, in Sweden normally we call it the smorgasbord, that it means you have a starter, main course, and the dessert in the same table. You pick anything you want. If you don't like a dessert, and you took more starter or more main course, how can we create as a smorgasbord of value system? And then of course we normally said, if this become a larger, and you can do a subset of that ecosystem, this has been one of the challenges we have. How can we work with the members and partners and working close to them together? That was and immediately said that we need a platform. We can't give it our commodity data or our original data from our machine connectivity and the tools immediately to someone else. That we need to have as a platform, service-enabled platform, make those services as shared together with the others and members in the ecosystem. And think about this digital disruption. If just about the disruptive forces we experience today, And first is the mass connectivity. And with the connected things, and this is rapid growth of the data availability. And I mean, you might heard about this, is the Gartner probably said that, or someone else, I don't remember that, but the data is the new oil. And because you have a large amount of connectivity and the growth of data, and then this is the fuel for digitalization. Another dimension is, and in manufacturing, increased drive in the manufacturing, reduce the waste. And we normally are helping very much about that. What can we do? How much you can use in the last piece of the tool, you can use it. I mean, our tools is not cheap. It's an expensive tool, but we normally explain to you about that. I'm going to show you how you calculate the remaining tool life, for example. Don't shift and change the tool before you use almost 90% of the lifetime of the cycle of the tool. And there is a very heavy calculation we are doing that, giving that kind of service. And then, of course, how can we make the sustainable business? It becomes more and more clear. And I mean, multiple stakeholders, and today and even yesterday I heard about talking about this how the sustainable business going to look like. And of course, we see based on that findings, disruption, we find a couple of opportunities for us. One of the largest opportunities in here is capitalize our machining knowledge. Even we have a tool company, we have a cutting tool knowledge. And normally I had a talk with Sal yesterday and we discussed about, okay, what machine MTM is doing. MTM is doing a great job. And what I'm saying that machine without tool, your vehicle without tires. But you need to have a tire, and the tire is the first contact with the material. When you started driving your car, and you started, everything's okay. When you started driving, when tire hits the road, and something happened with the car, depends on the road condition. The same goes for the material. And it's very important to us to have that combination. Normally we're saying that kinematics of the machine and the dynamics of the tool, them together, you have a digital machining. Otherwise, we say so that we can just only talk about the focus on the tooling. This normally has a good machining knowledge being captured together with the machining knowledge. That increased the value, that developed a completely new revenue stream for us. And of course, the last one is, and I've been always supporting our customers, to reduce waste, improve productivity. It's mentioned that predictive, when insert is being worn out, which is the cutter on the top on the tool. And tool breakages, very expensive for anyone on the production. And they provide insight, continuous improvement in your production. And of course, not everything is perfect like that. And then of course, we have a few challenges too. And this is a very attractive market. I mean, this discrete manufacturing market is not so mature also like is in telecom market. And newcomers is coming. And we believe that in this attractive market, and there's several people want to take care of the big portion of that. And we normally seeing the new type of competitors popping up. And that was we made a couple of years ago, looking for our closest competitors. And we said that nothing happening there. They're doing as much as we are doing, but that wasn't the case. The completely new integrators, the company we never heard about, the company doesn't exist for 5 years ago, has popping up, taking the data, doing some calculation. We said that properly. I mean, this is normally be saying that they want a part of the completely new value chain. For us, it's absolutely welcome. Don't misunderstand me, but it's a value chain privacy. Piracy in the value chain becomes more and more actually in this area. And okay, when we're building, we normally said that let us focus on the value chain as being used on the digital machining on the customer side. Our ambition and the business strategy developed our business in 2 dimensions. One of them is, close the machine, design, customer value chain, more precise on the design on planning on the left-hand side. Because normally you start with the design, you make the process planning, operation planning, production logistics, and then this is horizontal processes, and then connected on the vertical processes, machining processes, and then of course finally add in the verification, which is the measurement data from the methodology. And how can we have that expand our offering to our home turf, which is the more on side of the machining event, but make that total digital context together, both left-hand side and the right-hand side. And the ambition in here, which we are not saying right now, we're preparing for something called digital twin. Preparation on the left-hand side and measurement on the right-hand side, production in the middle, that it means you prepare something, you do something, and you measure, and then just check the digital gap is as small as possible. That is our own business model. And to turn that is, I'm going to show you right now, is about our so-called service enablement platform. And we take that, from left-hand side to right-hand side, turn it back, is most of the customers coming back to us, those design and optimization you guys is working with that is excellent. And can you use that in the machining? Yeah. The result from the machining, can you feed it back to the design and optimization again? That because next time when I start the next batch, I can reuse that lesson learned or the findings. And for that purpose, we have developed planning solution software to them to have. We have an IoT solution close to the machining. We have a quality solution close to the verification. We have intelligent tools, which is the sensor-based intelligent tools, which you come in much closer to the cutting operation that is a normal machine is doing, because machine connectivity is on the spindle level. If you're coming to the tool, normally there's a tool, there is an adapter, there is a holder, there is a spindle. If you check the information for the spindle level, if you have a sensor on the tool, and I can get immediately information from the tool level, what tool is doing. And that was the start of the service-enabled platform. After a couple of years development of the platform, we have shown that platform is just on the conceptual model in IMTS in 2016, and huge response back from the customer. And that wasn't our aim to sell anything, but that was very good done. In that time, people believed that was already just on I'm not saying the mock-up, but it's a little bit more than mock-up, but this is just on the proof of concept. And we came back home in 2016 and working very hard to create the new platform. And today platform look like that. There is a one-hand side, we have the machine and device connectivity. And we are very keen on the work in the shop floor level, close to machine computing, one-layered architecture, and then shop floor computing. We have that distinction between machine, close to computing, and shop floor. On the other hand side is the cloud computing. We're using the cloud capabilities in the IoT hubs and event hubs, and then analytics, big data analytics and the stream analytics, what we are doing. And this is the yellow dotted line, which is normalized saying this is vertical. Isn't horizontal in the picture, but it's vertical, and then connect to the backend, Sandvick Coramount backend processes, and the other Coramount cloud application like tool library, tool guide, which supporting customer design and planning. Then you have a holy T model, horizontal and vertical together. The challenge again here is to find that particular connection points when horizontal or vertical cuts to horizontal. That happens something because about the information model versus data model. That is the little bit challenge. And on the machine side, we have, as mentioned we have a couple of intelligent tools we are launching, and sensor-based tools, and of course CNC machines, and you can find the robots. We have a very early phase on the robots connectivity, and robotics is on the way, and we have a good on measuring machine size and hexagon. And those has been doing the reason for that, you need to make a connector. And there is several different connectors can be used here. If you can the machine side, we're using, is an OPC UA, one connector, empty connect, another connector, and we have an MQTT, another connectivity language you can use it. But the beauty of that, you pull the data not just only from machine. You pull the data machine, depends on how accurate you have, because we have challenging saying the customer that we can give a response less than 5 seconds, 6 seconds, milliseconds, 5 and 6 milliseconds, and that it means I need to do something else on the closed machine level, in the PLC level, put another box to make that connectivity. this connectivity we have supporting the 5 milliseconds and the edge intelligence size is a distributed architecture, and which normally, if something happens with the machine, we can't wait to response back to the cloud. Because if you have to turn that information up to the cloud, back to the machine is almost taking 10 times more. Is that 5 milliseconds or 6 milliseconds becomes a 10 and 60 or 65 milliseconds. We can't wait for that because machine is, in the RPM and the spindle is in normal is in between 10,000 up to 20,000 RPM, and that generates a 1.2 kilohertz data, which is normally we talk about the 6-7 milliseconds response time. You need to act very quickly. And this has been done. Why does it chop these small pieces? And this box with the edge intelligence, you close to the connectivity and the intelligence close to the machine, and there is a portal. It's a local portal connect to that. You can, machine operator can immediately take in an action. And on the shop floor level, we do the back-end connectors, connecting the MES system, manufacturing execution system, and then adding more shop floor intelligence. The first part we're calling the hot path analytics, which is the signal processing analytics. The second one is an aggregated data from the signal processes. Finally, all data send it later on, process data send it to the cloud intelligence, which you have in the entrance on the cloud, as put in the data lake. And then you use in the cloud portal, reporting analytics and application services. And machine learning is crucial for us, that it means most data is being stored. But another lesson learned, you can't work with the machine learning as long as you don't have those use cases, enough data to calculate. Another, buzzword called artificial intelligence. I can honestly say that I couldn't find an application of that. And the self-going machines or tools and et cetera doesn't exist right now. You need to have a bunch of data, bunch of learning, bunch of use cases to create that kind of artificial intelligence. It's very difficult. I mean, you can teach the car, you can teach to anyone, you go back and forth on the left. It's absolutely okay. You can teach it. But it never be in the use case in how we go to the right, or how we go to the up, how we go to the down. You need to take all 4 different coordination together to make them some kind of learning. And most of the artificial intelligence, I'm saying that people talk about that is just only doing few things on the left-hand side, on the right-hand side. I never seen that somebody covering all those movements, back and forth, up and down, together under the same umbrella. The magic on the left-hand side is I can pull the data from all 4 different units, measuring machine, robots, CNC machine, intelligent tools, timestamp the data, calculate the data in the same time. That is not just only one sensor in the machine and one sensor in the tools and do something about it in the cloud. It's not the case. My speech is over. Now is some live demo. I promised to show you guys. Sorry, Jürgen, this is I need to bring this up. We mentioned this, the data is the new oil, which is the oil and that, devices. What we are doing here is we are pumping that oil, if you're using that metaphor. You have a piping that oil, and then you're sending to your refineries, and they do anything you want with that. Okay, some demo. This is the live application, is installed in the 3 production units. And I was very keen on that, is normally go to choosing the first customer and testing that application. And I got a good lesson learned from my management, and he said that, eat your own dog food. Test in our production. Or in French, we say that, drink your own champagne. And tested that, bring us a use case. If it works, and then we go to the customer. We do a little bit differently because we're starting like that is an embedded solution and a service-enabled solution. Nobody knows what you are doing. But if you show that at the use cases like that, people say, wow, gee, it's working. And okay, how can we make the business case on that? And we're supposed to do in the business case before we develop things, but this is a little bit vice versa when we work in this area. And we have a couple of installations been done, and we have 7 machines in US, in North Carolina. We have a couple of machines in China, just testing. This was just only testing one in each continent. One production units. We have roughly 18 production units doing the so-called tools development. And for your information, we are one of the large customer, Sandvick production units, because they are using our own tools to make new tools. And let us see what's going on in this. We go to US. We can see what's going on there. And normally, what you see, about the layout of the factory, where is the machine is placed, and you can see the machine is going or not going, running, and then you can see the monthly runs on the machines, and you can see the activities. You can click on the machines. And immediately we pull the signal from the machine. And we pull the signal every milliseconds, but we publish it every 5 seconds, on the graphics in here. And these signals, we normally check in what's going on about this. Very important about this, the machine spindle feed and speed on the axis and the spindle. We normally look into which speed they have, which load they have in an axis. We normally think it's any immediate events. And if there is any tool breakage, and then you go down to see tool utilization comparison, that means how tool is being used in the machine. And there's a bunch of tools. I don't know if you're familiar with the multi-purpose machines, that is the magazine of those machines. You can have up to a couple of hundred tools, one of the largest one. Minimum 50 tools and 50, 60 tools in the same. And you can see most of the used tools in the machine. Here is the funny things is coming up, this remaining tool life. We're working very hard to give you, lifetime of the tool. When he can use the tool, when is, a lot less than. Those couple of reds, we're putting the couple of signals and normally in the least used tools. And now we're coming to horizontal connectivity. You can check, we will see if open, I don't know the network. And he loaded the graph of the geometry. Little bit low network right now, but it's on the way. And you can make your assembly builder. Now his tool is there. Say nothing. This is a 3D geometry. And then we can have see how can I make the tool in the more tool information. And a little bit more about that. He's giving you, open up to show you about the tool information. This is a little bit slow, this. So many people is just using the network right now. But okay, let them work.
You probably need to.
Yeah. And then of course, the second part is that we can make the machine analytics. You can hold all the factories together. In that time, I have a production unit GMO, and then you can see the tool utilization, how we used. You can cut down now, take the specific day, how tool is being used. And you can have a more advanced machining analytics, be doing some simulation of the tool. You see that tool is running, just following exactly about what the movement we have in the machine. And we have advanced Power BI reports. There is one of them expert area reports, and the technical area, expert area reports, and other reports. These reports, I believe, that's more important for anyone. One of them, we normally, during the operation, we normally checking exactly tool breakage calculation. This is reading data from the cloud, from the data lake, doing the calculation. This is the calculation we use in machine learning. You can see that there is a tool breakage in here. You can immediately check. I can show you here exactly what code has happened. The NC code machine is running during that tool breakage. Very valuable information. You can go back to the data. You can check what data is originally coming before the breakage. What's happened, after the breakage, nothing to do because tool is broken. You need to stop the machine. And those kind of things is predictive is important. Most of the data we're storing in here is those data is being used and to so-called our remaining tool life calculation. That it means we're using the collected data, calculated data, processed data, feed it back to the machine learning to creating the new algorithms. All new algorithms we have is train on the cloud side and then feed it, send it back as a web services to either on the edge client close to the machine or the shop floor side where do you want to do your calculation. I don't know, I can talk everything on that side. I mean,
No,
I'm done.
Excellent. All right. Well, thank you very much, Nevzat.
Yeah.
That's